In this video, we'll be taking a look at rationalizing limits. And to rationalize a limit, we need to find the conjugate of the radical. And so, to rationalize our current problem, we would have the limit as x approaches 4 of x minus 4 divided by 3 minus the root of x plus 5 multiplied by 3 plus the root of x plus 5, which is the conjugate, divided by 3 plus the root of x plus 5. Now that we've done this, we can go ahead and multiply our numerator by our numerator and our denominator by our denominator. And so we will have the limit as x approaches 4. For the time being, leave the numerator as is, so x minus 4 into 3 plus the root of x plus 5. This will make our job a lot easier, but we should go ahead and follow the denominator. And so 3 multiplied by 3 would be 9. 3 multiplied by the root of x plus 5 would be 3 root x plus 5. Negative root x plus 5 multiplied by 3 should be negative 3 root x plus 5. And negative root x plus 5 multiplied by positive x plus 5 should just give us x plus 5. Well, negative x plus 5. Sorry about that. And now that we've foiled our denominator, we can go ahead and cancel these two. And so we'll be finding the limit as x approaches 4 of x minus 4 multiplied by 3 plus the root of x plus 5 divided by 9 minus x plus 5. This should become the limit as x approaches 4 of x minus 4 multiplied by 3 plus the root of x plus 5 divided by 4 minus x. And now that we found this, we would like to cancel this figure right here, x minus 4, and cancel it with this. Now we need to make this look a lot more like this, and so we could take out negative 1 from this from our denominator, and so this should be the limit as x approaches 4 of x minus 4 multiplied by 3 plus the root of x plus 5 divided by negative 1 multiplied by x minus 4. And so these two would cancel, and so our final would be the limit as x approaches 4 of 3 plus the root of x plus 5, but this will be negative as it's divided by negative 1. And now we can go ahead and plug the number 4 in for x. So this would become negative 3 minus the root of 4 plus 5, which should be equal to negative 3 minus 3, and our final answer should be negative 6. So that will be your answer for this problem. Now let's move on to another problem, and let's say we had the limit. Let's say we had the limit as x approaches 25 of 5 minus the root of x divided by 25 minus x. Now to rationalize this limit, we need to find the conjugate of the radical. And so our new problem would be the limit as x approaches 25 of 5 minus the root of x divided by 25 minus x multiplied by 5 plus the root of x divided by 5 plus the root of x. And this would be the conjugate of our radical in the numerator. And so to solve this, we can go ahead and multiply the top by each other and the bottom by each other. And so this then becomes the limit as x approaches 25 of 5 multiplied by 5, which should be 25, plus 5 root x minus 5 root x minus x, as root x multiplied by root x would be just x. So we have negative x right here, and we divide this by our denominator, which should be 25 minus x multiplied by 5 plus x, or 5 plus root x. As we mentioned before, do not FOIL our denominator just as yet, as this would make life much easier when solving the problem. So 5 root x minus 5 root x is 0, so these two would cancel, and so we are left with a limit as x approaches 25 of 25 minus x divided by 25 minus x multiplied by 5 plus the root of x. Now, as you can see, our numerator has this equation down here as, or this expression in common, so they would cancel. So that would be the reason we do not FOIL our denominator here. As you can see, it made our lives much easier right here. So this then becomes the limit as x approaches 25 of 1 divided by 5 plus the root of x. Now we can go ahead and have a direct substitution done. So this becomes 1 divided by 5 plus the root of 25. This would become 1 divided by 5 plus 5, or 1 divided by 10. And that would be our limit for this problem. Now let's try another one, and I'd like for you guys to try this for yourselves. Now let's say we had the limit as x approaches 0 of root x squared plus 1 minus 1 divided by x. Go ahead and try to solve that one for me, guys. You can pause the video. Now, as we did before, we'll be finding the conjugate of a radical, and so this will become the limit as x approaches 0 root x squared plus 1 minus 1 divided by x multiplied by the root of x squared plus 1 divided by the root of x squared plus 1 plus 1. Now that we found the conjugate of a radical, we can go ahead and multiply the numerators and the denominators. And so this will become the limit as x approaches 0 of x squared plus 1. So the root of x squared plus 1 multiplied by the root of x squared plus 1 would just be x squared plus 1, as the two square roots would cancel. Then we would have plus 1 multiplied by x squared plus 1, the root of x squared plus 1. So we'd have x squared plus 1 minus the root of x squared plus 1 minus 1 divided by x multiplied by the root of x squared plus 1 plus 1. As we mentioned before, we do not FOIL our denominator, as this would make our lives much easier when solving the problem. Now, these two would cancel, they become 0, and these two would cancel. And so this becomes the limit as x approaches 0 of x squared divided by x multiplied by the root of x squared plus 1 plus 1. Now we can go ahead and cancel the x in the denominator with one over x up here. And so we would lose our 2. And this then becomes the limit as x approaches 0 of x divided by the root of x squared plus 1 plus 1. We can go ahead and do a direct substitution. So this becomes 0 divided by the root of 0 squared plus 1 plus 1. And so this becomes 0 divided by the root of 1 plus 1, or 0 divided by 1 plus 1. Final answer would be 0 divided by 2. And so that would just be 0. Now, as you notice, it is 0, but we do not have an instance where the limit does not exist because we have a number in our denominator. If our denominator was equal to 0, then that would mean our limit would have a vertical asymptote, which would mean there would be no limit. So no limit exists. But because there's a number in our denominator, this means that the limit does exist, and that limit would be 0. Now let's move on to another problem. And let's say we had the limit as t approaches 0 of t squared plus 9, and that will be the square root of t squared plus 9, minus 3 divided by t squared. Now, to solve this, we're going to find the conjugate of our radical. So that'll be t, the limit as t approaches 0 of the root of t squared plus 9 minus 3 divided by t squared multiplied by the root of t squared plus 9 plus 3 divided by the root of t squared plus 9 plus 3. Now we can go ahead and FOIL our numerator. So this then becomes the limit as t approaches 0. Now the square root of t squared plus 9 multiplied by the square root of t squared plus 9 just becomes t squared plus 9. T squared, the square root of t squared plus 9 multiplied by 3 becomes 3 t squared plus 9. Negative 3 multiplied by the square root of t squared plus 9 becomes negative 3 t squared plus 9. And negative 3 multiplied by 3 becomes negative 9. And we can divide that by t squared multiplied by the square root of t squared plus 9 plus 3. Now that we've done this, we can go ahead and eliminate. So we can eliminate this as they both become 0, and these two as they become 0. And so our final would be the limit as t approaches 0 of t squared divided by t squared multiplied by the root of t squared plus 9 plus 3. Now these two would cancel, and so we're left to find the limit. We're left to find the limit as t approaches 0 of 1 divided by the root of t squared plus 9 plus 3. Now we can go ahead and do our direct substitution, and this becomes 1 divided by the square root of 0 squared plus 9 plus 3. Then this becomes 1 divided by the square root of 9 plus 3. or 1 divided by 3 plus 3, which makes our final answer 1 divided by 6, and that would be our limit for this problem. Now let's move on to our next example, and I'd like for you guys to try this for yourself before I attempt. So let's say we had the limit as x approaches -4 of the root of x squared plus 9 minus 5 divided by x plus 4. Go ahead and try this. You can pause the video and take a whack at this. Now, before we are able to attempt, we need to find the conjugate of our radical. And so this becomes the limit as x approaches -4 of the root of x squared plus 9 minus 5 divided by x plus 4 multiplied by the root of x squared plus 9 plus 5 divided by the root of x squared plus 9 plus 5. Now that we found the conjugate, we can go ahead and multiply our numerators and our denominators. And so this becomes the limit as x approaches -4. Now the square root of x squared plus 9 multiplied by the square root of x plus 9, the square root of x squared plus 9 becomes x squared plus 9. Now the square root of x squared plus 9 multiplied by 5, this becomes 5 root x squared plus 9 minus 5 root x squared plus 9. As we're expanding the numerator, and -5 multiplied by +5 becomes -25, and this will be divided by x plus 4 into the root of x squared plus 9 plus 5. Now these two would cancel, and so this becomes the limit as x approaches -4 of x squared. Now -25 plus 9 becomes -16 divided by x plus 4 into the root of x squared plus 9 plus 5. Now, if you take a look at our numerator, you'll notice that this is a difference of two squares, and so this would be the limit as x approaches -4 of x plus 4 into x minus 4. So that is the factored form of x squared minus 16, and that will be divided by x plus 4 multiplied by the square root of x squared plus 9 plus 5. Now these two would cancel, and so we're left to find the limit as x approaches -4 of x minus 4 divided by the square root of x squared plus 9 plus 5. We can go ahead and try our direct substitution now. And so this becomes -4 minus 4 divided by the square root of -4 squared plus 9 plus 5. This then becomes -8 divided by the square root of 25 plus 5. This becomes -8 divided by 10. And so our final answer is -4/5. And that would be our limit for this problem. Now, finally guys, let's take a look at another example, and that will be it for our video. So let's say we had the limit as x approaches 0 of the square root 2x plus 1 minus the square root of 3x plus 1 divided by x. Now, as we did before, we will rationalize or radicals. So this will be the limit as x approaches 0 of the root of 2x plus 1 minus the root of 3x plus 1 divided by x multiplied by the square root of 2x plus 1 plus the square root of 3x plus 1 divided by the square root of 2x plus 1 plus the square root of 3x plus 1. Now that we have found the conjugate, we can go ahead. Now that we have found the conjugate, we can go ahead and find our answer. And so let's go ahead and multiply our numerator. So this becomes the limit as x approaches 0. Now the square root of 2x plus 1 multiplied by the square root of 2x plus 1 becomes 2x plus 1. And the square root of 2x plus 1 multiplied by the square root of 3x plus 1 becomes square root 2x plus 1 square root 3x plus 1 minus the square root of 2x plus 1 root 3x plus 1 minus 3x plus 1. And this will all be divided by x multiplied by the square root of 2x plus 1 plus the square root of 3x plus 1. Now 2x plus negative 3x becomes negative x, so we'll have the limit as x approaches 0 of negative x. These two would cancel, and so we will have that divided by x multiplied by the root of 2x plus 1 plus the root of 3x plus 1. Now these two would cancel, and this will become the limit as x approaches 0 of negative x, or negative 1, sorry, divided by the root of 2x plus 1 plus the root of 3x plus 1. Now we can go ahead and have our direct substitution done. This becomes negative 1 divided by the root of 2 times 0 plus 1 plus the root of 3 times 0 plus 1, which is then negative 1 divided by the root of 1 plus the root of 1. This becomes negative 1 divided by 2. And that would be our limit, negative a half. And that will be it for our video today, guys. Thanks a lot for joining. Please stay tuned for more great content, and hit a like if you like the video and comment down below, okay?